Thank you, sir.
Okay, now we have last part, uncertainty calculations.
এটাই শেষ স্যার?
Yeah, last part is uncertainty calculations, and there are some rules for uncertainty calculations. You see, you have to focus here. Focus in this is measured value and this is uncertainty. Okay, and that
Yes,
is
sir.
called absolute uncertainty. So
Uncertainty.
if you can identify these two, then you can do any of the uncertainty calculations easily. So what is the first rule? Can you read this first rule?
So for quantities which are added or subtracted to give a final result, add the following add the fractional uncertainties.
Okay, so look here, we have 1.5 plus 0.2, right?
0.2. Yes, sir.
So we actually did here wrong. This one you cut in your note, you cut it. You should write here absolute uncertainties. I should also correct it. Add the absolute uncertainties. Okay, for
Yes, sir.
quantities which are added or subtracted to give a final result, add the absolute uncertainties. Okay, you already got this is human error, right? Optional.
এটা কি স্যার ইচ্ছা করে করা ছিল আপনার?
No, this is my mistake. When I wrote, then mistakenly I wrote here fraction. It should be absolute uncertainties. Okay, so here it should be 0.2. This is absolute uncertainty, and here is I. This one is I1. This is I2. Okay, there
Yes,
is
sir.
one circuit here. You see, there is the circuit is in parallel connections, two resistors, and you know in parallel connections current is divided into two parts, isn't it?
জি স্যার।
And now when someone is measuring the emitter in this side I1, the accuracy level is 0.1, but in emitter I2 the accuracy level is 0.2. You understand it? How we
Yes,
get
sir.
the absolute uncertainty? The
No,
smallest
sir. Can
division.
you repeat it once again?
Yeah, like we are using two emitters here. In two branches,
Yes,
we
sir.
are using two emitters. So one of the emitters, its accuracy level is 0.1 ampere. Okay, like the smallest value, it can measure accurately till 0.1 ampere. But the other emitter is 0.2 ampere. It can measure like the ruler. Ruler one I
Okay.
gave you, that ruler can measure till 0.1 centimeter accurately, isn't it?
Yes, sir.
So emitter also has the limit that some
স্যার
emitters.
আপনার কি ল্যাপটপে ওই সমস্যাটা আছে?
Are you feeling any
কথা তো ভেঙে
problem?
ভেঙে আসে।
Are you feeling any
ইয়েস স্যার,
problem?
কথা তো হ্যাঁ হ্যাঁ কথা তো ভেঙে ভেঙে আসছে, মানে ওই যে আপনার
Still
ফোনের
it has
সমস্যাটার
problem.
মতো হচ্ছে।
Still it has
না,
problem.
এখন ঠিক হয়েছে, এখন আবার ঠিক হয়েছে।
Maybe sometimes there is fluctuation in the network for that reason. Okay.
Okay.
Okay. Now what I was saying that your ruler has accuracy level 0.1 centimeter, right?
Yes, sir.
Isn't it? So in
Yes, sir.
emitter normally the accuracy level is still 0.1 ampere. Okay,
Yes.
but some of the emitters they have accuracy level till 0.2 amperes. Okay, so here we are
Yes, sir.
getting two absolute uncertainties. One is 0.2, another one is 0.1. And when we are
Okay.
adding the values, we are adding the measured values like 1.5, 2.0. These are measured values. Okay, and
Yes, sir.
0.2, 0.1, these are absolute uncertainty. So that time what we are doing, we are adding the absolute uncertainties separately, and we are adding the measured values separately. Then you got how much? 3.5 plus minus 0.3. Is it
Okay.
clear? This is rule
Yes,
1.
sir.
This is rule 1.
Rule 1.
Okay, now Rule 1, another example. Rule 1, another example.
Another example.
Can you read here?
Yes, sir. In an experiment, a liquid is heated electrically, causing the temperature rise from 30 plus minus 0.2 degrees centigrade to 41.5 plus minus 0.5 degrees centigrade. Find the change in the temperature with uncertainty.
So the previous one we got addition of the current, isn't it?
Yes, sir.
Now we have to subtract the temperature value, right? To get the difference between the temperature,
Yes,
isn't
sir.
it? So now what we are doing, we are subtracting the measured value 41.5 minus 30. How much it coming? 11.5.
5 plus minus 0.7.
Now there is the here main thing we have to focus. Look here, we are subtracting the measured value, but during uncertainty, absolute uncertainty, we are adding that. Is it clear?
Yes, sir.
So whatever you are doing, you are adding or subtracting the measured value. Always your absolute uncertainty should be added.
Okay.
This is the main thing you have to focus here. Okay.
Okay, sir.
In the previous example, you added the current and you also added the uncertainties, isn't it?
Yes, sir.
But here you subtracted the measured value. Even after that, the uncertainties are added. So uncertainty always you are getting added. Is it clear?
Yes, sir.
So this one you have to remember it, and you should focus here that uncertainty is always added during subtraction or addition both.
Okay.
Okay, now rule 2.
For quantities which are multiplied together or divided to give a final result, add the fractional uncertainties. As for example, if x equals to
Yes.
ayz, a is a constant.
Okay,
Fractional
this one,
uncertainty.
yeah,
Yes, sir.
this one is giving you multiplication. Okay, you are getting one uh, product. You see,
Yes, sir.
x is the product of multiplication of yz,
Yes, sir.
isn't it? So during this type of multiplication, how we calculate the uncertainty? We get the fractional uncertainties. Add the fractional uncertainties. Okay, so how we do that? Look, we have here del x by x. Del x by x. What is del x? Del x is the absolute uncertainty in x.
Yes, sir.
If you are measuring x, you will get some uncertainty in x, isn't it?
Yes, sir.
So this uncertainty is del x, isn't it? So del x by x will be equal to del y by y plus del z by z.
Red.
Is it clear?
Yes, sir.
So the fractional uncertainty of x, which one is the product, is equal to the addition of fractional uncertainties of the two variables which you multiplied. You multiplied yz to get x, isn't it?
Yes, sir.
So to get the fractional uncertainty of x, you have to add the fractional uncertainties of y and z. Is it clear? I am
Yes, sir.
showing you some examples afterwards, then you'll understand it more. Now look here, I gave here one example that this formula or this equation where is applicable, and this rule is where it is, how it is applicable. Look, we know this formula, right? P equals rho gh. You know this formula. Pressure equals
Yes, sir. Rho gh.
density multiplied by g, acceleration due to gravity, then height. We know that, isn't it? Now,
Yes, sir.
the given values for rho density is 13,600. Then uncertainty in it is plus minus 100. Okay.
Yes, sir.
Then for acceleration due to gravity, we have 9.81, isn't it?
Yes, sir.
Farhan,
Yes, sir.
9.81, and the uncertainty in G, how much? 0.02. Is it clear, Farhan?
Yes, sir.
So H is how much?
0.762 plus minus 0.005 meter per
Okay,
second square.
plus minus 0.005. So this way we are getting measured value and uncertainty in each of the quantities. We are getting for density, we are getting for G, and also we are getting for H, all of them, right? Now, how
Yes,
to
sir.
calculate the fractional uncertainty? We have to check here. Yeah, look at this question. What is the value of P with its uncertainty when stated to an appropriate number of
Appropriate
significant
number of
figures?
significant. Yes, sir.
So if you calculate, then your P will come H rho G. Which one is measured value? You got the measured values, right?
Yes, sir.
For rho it was 13,600. For G it was 9.81, and for H it was 0.762. These are measured values. So when these three values you are multiplying, you are getting how much? 1.02 into 10 to the power 5 Pascal. Okay.
Yes, sir. Yes, sir.
Now the fractional uncertainty. How will calculate the fractional uncertainty? Del P by P. We are going to find the fractional uncertainty of pressure, and for that we are adding the uncertainties in H, rho, and G.
G.
In rho we got 100, right?
Yes,
The
sir.
absolute uncertainty we got 100, so 100 by the measured value, that is giving you the fractional uncertainty.
Okay.
Then 0.02 divided by 9.81, that is for G, that is fractional uncertainty.
Okay.
Then for H, it is 0.005 divided by 0.762. Okay, if you
Yes, sir.
calculate the bracket, inside the bracket, whatever you are getting, if you calculate, it will come 0.016. How much is coming?
0.016.
0.016. So 0.016 is your addition of all this fractional uncertainty. If you multiply with this P you got how much? 1.02 into 10 to the power 5, isn't it?
5. Yes, sir.
So 0.016, if you multiply with 1.02 into 10 to the power 5, it will come 0.016 into 10 to the power 5 Pascal. What is your absolute uncertainty in P?
Okay.
Is it clear?
Yes, sir.
So P plus del P equals 1.02 plus minus 0.02 into 10 to the power 5 Pascal.
10 to the power 5.
You got here for the P value is 1.02, isn't it?
Yes, sir.
And for absolute uncertainty, you got 0.016, which you are rounding up. Look, what you are rounding up 0.016, then it will come 0.02, isn't it?
Yes, sir.
Then we are writing it here, and we are getting altogether absolute uncertainty and the measured value 1.02 plus minus 0.02. So it is the answer, okay?
Yes, sir.
And we got this question in MCQ 10. If you go to MCQ 10, then you will get this question. So our one question is done.
Yes, sir.
Okay.
Yes, sir.
Now here we have another uncertainty. That is the previous one we had multiplication, but we did not have any power, right? You
Yes,
see,
sir.
we have here power y to the power a, z to the power b. So if there is power, how to calculate the uncertainties? Fractional uncertainties. That time what we'll do? The same thing like before. This power will just come front of this fraction. Is it
Okay, sir.
clear? B will
Yes,
come
sir.
here del z by z. Then A will come in front del y by y. Okay. Now
Yes, sir.
where we can apply this? I gave you one example here to get the application of this formula. Can you read this?
Surely, sir. খাতা দিয়ে পড়ি?
Yes, sure.
A micrometer screw gauge is used to measure the diameter of a small uniform steel sphere. The micrometer reading is 5.00 millimeter plus minus 0.01 millimeter. When the value of the volume of sphere with its uncertainty, sorry, proceed.
Okay. What is the value of volume of sphere with its uncertainty? Look here. We got the diameter of the small uniform steel sphere. We got the diameter only. Now we
Yes,
are
sir.
asked to find the volume of. We have to find the volume of it with its uncertainty. Now, volume of a sphere, how to measure, you know, right? Hello?
Yes, sir.
Formula of volume of sphere is 4 by 3 pi r cube, isn't it?
Okay. Yes, sir.
Then if you put the values here, 4 by 3 pi, then our
R
value
cube.
is 5 by 2. Okay, 5 by 2 10 to the minus 3. Because it is in millimeter, we have to convert to meter.
Meter.
Okay, then it comes
Yes, sir.
this one 65.45 into 10 to the minus 9 meter cube. Okay,
Yes, sir.
now we got here power, right? R
Yes, sir.
cube. R cube is the
R cube.
uh,
Power.
power. So like our previous example we got here in the formula, this 3 will come front, right?
Yes, sir.
When we are measuring del V by V, then we are having 4 by 3 pi, these are constant, right? 4
Yes,
by
sir.
3 pi, these are constants, so we are not taking them here in our calculation. For fractional uncertainty, we are taking only radius. Okay,
Yes, sir.
radius is here r to the power 3, so 3 will come from then del r by r. Is it clear?
Yes, sir. Yes, sir.
Okay, now we have here already we calculate the volume, that is 65.45 into 10 to the minus 9 meter cube. So we are using that one. Look
Yes,
here,
sir.
we have 3 multiplied 0.01 by 5. Okay, from where we got this? From here, the given value. See, 5 and 0.01. 0.01 is our absolute uncertainty, then divided by the measured value, 5 millimeter. So
Yes,
it's
sir.
coming, look, this V is multiplied with this value. V was here 65.45 10 to the minus 9. So if you multiply the value of V here, it comes 0.39 into 10 to the minus 9 meter cube. Okay.
Yes, sir.
Now the measured value of volume you got how much? 65.45, and the absolute uncertainty is 0.39 into 10 to the minus 9. So here in the bracket we are writing 65.45 plus minus 0.39 into 10 to the minus 9. Is it clear?
Yes, sir.
Okay. Please go through, huh? Try to understand. Again we will repeat, no problem. Then we'll
Inshallah.
understand more. So this part is left, huh? Only this part. That is
Yes.
percentage uncertainty.
Yes, sir. And
Ratio
on
of,
by Friday, I will surely send you the documents.
inshallah, inshallah. May God bless you. You are really
Sure, sir. May
cooperating
God
me.
bless
I
you
am
too.
really inspired by your hard work, mashallah.
Ah,
And
yeah.
this is inspiration also for me. Okay.
Inshallah, sir.
So look here, percentage uncertainty is the last one. Already I told you, whatever you uh, got in your fractional uncertainty, if you multiply with 100, that is coming as percentage uncertainty. So percentage uncertainty is actually the other form of fractional uncertainty.
Okay.
Is it clear? To go to
Yes, sir.
percentage uncertainty, you need fractional uncertainty. Okay.
Yes, sir.
So it is only making it 100%. That's it. So can you
Okay.
read it, please? Percentage uncertainty.
So from the copy,
Yeah, yeah, sure.
the ratio of absolute uncertainty and measured volume multiplied by 100% is called percentage uncertainty. When two or more quantities are multiplied or divided to give a final result, then add all the fractional percentage uncertainties to get final percentage uncertainty.
So we already got this idea. Just here, in place of fractional, we are getting percentage. Is it clear?
Yes, sir.
Then other rules are all same. So that's
Okay.
it for today, huh? We are
Okay, sir.
done with
May
the
Allah bless you.
notes, and I uploaded the worksheet. If you can manage, you can get the printout. Okay.
Surely, sir.
Okay. Okay. Thank you
Okay,
so
sir.
much.
Allah
Allah
Hafiz, sir.
Hafiz.
Okay, sir. Allah Hafiz. Assalamu alaikum.
Walaikum salam.